So thanks again for the invitation and the opportunity here to show you how we achieved in our new data center a quite good PoE while we have been using groundwater. So as mentioned, I'm the CTO. I'm in charge of all technical departments in our company and had the project with the data center done in the last year. Okay. So just to give you a short overview about our company, because it's not that known as Google or Microsoft. So we are a hosting company fully focused on dedicated hosting. That means that we give our customers the ability to rent a server from us on a monthly basis, and then this server is put into our data center, either in Europe or in the US. We are located in Cologne, and we are operating 2 data centers, one out of Strasbourg in France, and one out of St. Louis in the US. Altogether, we have around 25,000 to 30,000 servers at the moment, which we are running in our data centers. Around 80% of them are located in the European data center. This direction. Our brands, so we have several brands which we are marketing. We start from the very low end, where it's very important for us to have a very good price-performance ratio. So the cost in order to host a server is very important for us so that we can compete on the market and it can attract customers. Throughout the value chain, we are adding more and more services to our products. And so from Server for You at the very low end, without any service, to Serverloft, where you have self-managed features, up to PlusServer for managed hosting, we have the full range of products. What is special with us is that on the one side, there are no people coming to our data center, so we don't do any co-location. We are just renting the servers we have bought and put into our data center. We have full control about which products we are offering on the one side, but on the other side, we have seen that it's important for our customers and for marketing that we can use brand server hardware. So we are working with guys like Fujitsu and HP. For example, we are the biggest buyer in number of servers of Fujitsu servers worldwide, and we put them in our data center. So there we have only limited possibilities to change the hardware or to put UPS into the server. So we need to try to fit with what the server manufacturer are giving to us. On the other side, we cannot use any principles where we say, okay, we have a container and we just go in there for once a week in order to repair the stuff. Every server is an individual customer, and so when the customer has a problem or a hardware issue, we cannot just move it to something else. We really need to repair the server. So we have to run somehow a normal data center operation, like the big Equinix guys and something like that. But on the other side, it was very important for us to be very efficient and to be very, very price conscious. So when we built our data center, so years before, we have just been co-locating. But in 2008, we decided that the time has come that we have to build our own data center. And so we looked around. So we always wanted to be a little bit innovative in what we do. And so we looked around what kind of possibilities we have to build our data center. We soon saw that France is the right spot for our data center. On the one side, due to the power pricing that is available there. On the other side, we saw that in the area close to the German border, there is lots of groundwater available. So we wanted to use this groundwater in order to cool our data center. Let me first give you a short video 3D tour through our data center so that you get a better impression. So it's in German, I'm sorry. I only had the German HD version, but I will explain what it is. So this is our building. We are located on the left side. You see the generator buildings up front of the building. And we have the Rhine River, or we have a bassin of the Rhine River exactly behind our building. So this is for security, our fences. We are using normal diesel generators, and we looked that we have very effective diesel generators, which also have not so much exhaust for the air. This shows you our wells. So we went down up to 80 meters in order to get our cool water. We have 2 of them to be fully redundant. This shows our heat exchangers, so we are piping the water against the heat exchangers in order to cool the whole data center. In the floors we have normal crack units who are putting the cold air below the raised floors, and then we're working with cold aisle containments. They have some smoke detectors and early fire detection systems in there. On the one side we are using normal rack servers, so we put just 40 servers in a rack. But on the other side we also have lots of desktop servers. So in the very low end we are using normal desktop servers you have under your shelf in your office in order to keep the cost for the hardware down. So let me just show you a small slide about our cooling concept. So in general we are using 2 wells for full redundancy. Each of our wells is capable in order to give us up to 680,000 liters per hour. We are running 2 pumps in each of the wells. So once for redundancy, but also in order to get this volume of water out of our wells. Then we are filtering the water. So if you have such big wells, you need to have some filters in order to prevent sand into your heat exchangers. And these filters are just checking the water before it goes to the heat exchangers. Everything is built redundant, so we have always 2 ways to each heat exchanger. We have 2 ways in order to go to our crack units. Everything is fully redundant, so that we can go from one circle to the other without getting any failure. Besides the groundwater cooling, we don't have any additional cooler, so we have no other cooling equipment. We are fully reliable on the groundwater, and that's why everything is redundant. We have 2 wells which are 300 meters away from each other in order to have enough water and to not force any problems. If we look into one of our wells, they are 60 meters deep, and we are taking the water from between 30 and 50 meters. So the 2 pumps are in the well above each other, and they are piping the water from 30 meters deep. This allows us to get the amount of water. So at the bottom of the well, it's still 80 centimeters in radius. So, no, not in radius, 80 centimeters broad. And then on the top, there's a little bit more space in order to get the pumps in. This shows you some pictures from the building phase of our data center. So there was lots of construction going on in order to get our wells built, and it took around 3 months when they started to build it. Some regulations we had to keep in mind. So when we started the project and when we saw that water cooling is the right way for us, together with the economic department of this area, we talked to all the regulating authorities. So what they told us is that we are able to take around 580,000 liters of water per hour. And we are also, in our calculations, we saw that this 100,000 liters equals around 1 megawatt of IT load. The temperature we get from groundwater, from all the historic information we looked at, showed us that it will be between 12 and 14 degrees. And that's also what we see today while the system is running. The maximum we are able to give the water back is around 22 degrees. So we don't bring the groundwater back into the ground. We have the good possibility to put it into a bassin which is connected to the Rhine River. So we don't have all the energy to bring it back down. We just can flow it into the river, and that's fine for us. What we have seen also is that the nature authorities, they asked us to put some oxygen in. So the water down there doesn't have many oxygen, and they just wanted to avoid that the fishes get any problems. And so they asked us to put 5 milligrams per liter oxygen in there, That's quite cheap to do, and it made a much better quality. And we see now lots of fishes at the part where we bring it into the river. What was also interesting for us is that the regulation said the worse the water quality of the river would have been, the higher we could have put water in. So it was bad for us somehow that the water quality was that good, and we had to stick to the 21 degrees. Some numbers about the power usage of the pump so that you get a feeling how much power it takes to pump that amount of water. So depending how much liters, 250 is the minimum we can draw with the pumps because they just have certain specifications where they can run at. With 250,000 liters, we're taking around 21 kilowatts. At 500,000 liters, it's around 62. So we are around 11 to 12 kilowatts per megawatt IT load, which adds to a PUE just 0.01% for the power usage of the pumps. All the power, other power, which is used inside the building for crack units and everything like that, is not calculated here. It's just to bring the water out of the ground into the data center. To give you an idea about the cost we had to invest so that you get a feeling if it's expensive or not. So the pre-study, in order to get all the authorizations, to get an idea if it's working or not, cost us around 20K. One of the wells was an investment for around 270K, so we had to do this 2 times, so we have a little bit more than €500,000. Then we had the piping. Since it was everything was very close to where we wanted to have the heat exchangers, it was only 110K to bring the water from the wells to our heat exchangers and from the heat exchangers to the bassin or to the river in order to bring it back. The pumps, there are 4 of them, are around 40K each, so 160 in total. And the oxygen adding and the building in order to bring it under the water into the water of the Rhine River, this was an additional 80K, and now we have to do yearly studies around 10K. So every year we have to check how the fishes are feeling, if everything is fine or not. And we made the first study beginning of the year, and they are all happy, and there are much more now than there was before. So it's really good for the river, and because of that, also the project is very much liked in the authorities, because they first of course saw, oh, we don't know what happens to the fishes, we don't know what happens to the nature, but since it's fresh water which we bring in, it's much better than it was before, and the oxygen we bring in is also much better for the nature at this certain area. So when we compared the capex for the groundwater cooling against other cooling types which would have been possible there, it was not only the most effective one, it was also the cheapest one from an investment point of view. The water which we bring out there, it's a little bit special in France. There is just a flat fee which you have to pay per year. It's around 10 to 12K. So it's really, really cheap to draw that amount of water. You get a flat rate for taking water out of the ground. And due to the area, there's so much water that there will be always water available, and we never had a problem or saw that we had to pump more in order to get more water out of the ground. That's just to give you a short overview. Since our company is also running the biggest hosting event in the world, I just wanted to invite all of you, if you're interested. It's an industry event. We're doing 3 times a year. It's in 2 weeks, it's in Bangkok for Web Hosting Day Asia. And next year it's a big event with around 3,000 people from the hosting industry in Germany in the Europa Park. So if you're interested in joining our event, please visit our website and sign up for it. That's a short summary of what we have seen in the last year with our new data center. We went live with it in October 2010. We moved all of our servers, around 25,000, into the new data center until Christmas. And since January, we are running live with the full amount of servers in this new data center. And we had no problem so far with our cooling infrastructure. Thank you.
Thank you very much. All right, we have time for a few questions.
Great. Could you tell us what filtration you used and what kind of maintenance the filtration requires?
The filtration we have, there are the 2 filters I mentioned in this schema. They're just
What type of filter are they?
again.
What type of filter? What's the design?
It's candle type. So you have different candles in there, I think around 50. And the system can clean itself. So whenever it gets full, we close some pipes behind it, so put up into more pressure into the system, and then it's taking out the sand or everything that is in there. At the moment, it's cleaning itself once a day. When we started, we had a little bit problems with the wells taking too much sand, so we had every minute to clean. But it went down now to once a day under full load. And even when we start the pipes very fast, from 0 to 100%, it still doesn't bring any sand anymore. So you need some time in order to clean your whole system and to clean your wells, especially when you have some time between finishing and getting into production. So this was around 7-8 months for us. And so a little bit sand had already got into the system. And then, but after 2 months of piping full speed, it was out again and we had no problems anymore.
More questions? Well, in this case, thank you very much.
Thank you.